Good morning and welcome to AP Statistics. Today I'm going to try to go over the practice test, which was on pages 78 through 81, and try to make it make sense. Good luck. So I'm going to be using the textbook in front of me and the answer key. We'll just talk through the problems and see how this goes. The first problem says you record the age, marital status, and earned income of a sample of 1,463 women. The number and type of variable you have recorded is what? So we're talking about quantitative and categorical variables. Quantitative variables are those that have meaningful value to them. Categorical variables are those that are essentially not mathematically significant, but they're labeled values. So we have, let's see, the age. Well, that's quantitative. And we have marital status. Well, that's categorical. 1 and 1. Earned income. Well, that's again quantitative. So we have 2 to 1. And that's all there is. So D is the answer. There's 2 quantitative and 1 categorical. We move on from there. Number 2, Consumer Union measured the gas mileage in miles per gallon of 38 vehicles from the same model year on a special test track. The pie chart provided information about the country of manufacture of the model cars tested by the union. Based on the pie chart, what can we conclude? Well, there's a number of things we can conclude, but I mean, look at the pie chart. We see that certainly the majority are U.S. made. There's a slim fraction that are Italian and French. Sweden is the next most, then Germany and Japan. But read carefully. It says A is Japanese cars get significantly lower gas mileage than cars from other countries. Clearly, Japanese cars are not in the majority here. Blah, blah, blah. E says more than half of the cars in the city were from the U.S. I mean, that's the obvious answer. It stands out. Obviously, again, looking at the pie chart, it's more than half of the circle, so it's obviously E. Moving on. If you have any questions, by the way, as to like, why wasn't it C? Just let me know, okay? But one of the things we can talk about here is if you look at all the answer choices, read carefully, one of them sometimes just stands out as obviously correct. So you don't have to worry about whether there's a thing about this one that is kind of right, but is it right or is it wrong? One of them usually stands out as the right answer. Number 3, which of the following bar graphs is equivalent to the pie chart? Well, again, we're looking at the relative share. U.S. has to be the most clearly, then Japan, then Germany, then Sweden, then France and Italy are about the same. So which model are you looking at? Well, that's not in descending order, but the heights that we just talked about, that's B. Obviously, the U.S. is the tallest. A can't be right. The U.S. and Germany are tied. C can't be right. Japan's more than the U.S. D is the next most plausible, but it fails in the Germany and French and Italian categories. It doesn't match up at all. Okay, we move on. Number 4. Earthquake intensity is measured using a device called a seismograph, which is designed to be most effective to earthquakes with intensity between 4 and 9 on the Richter scale. Measurements of 9 are given. They have an L and an H for the lowest and the highest, which we were not told. Now, L indicates earthquake had an intensity below 4.0 and H above 9.0. The median earthquake intensity is what? Well, obviously, put them in order. The L comes first, the 2 H's go last, the rest go in order, and the answer is B, 6.0. Okay, median is just the middle data point. It doesn't really matter what the L and the H values were, it's where they go. L goes first, the 2 H's go last. Moving on to number 5. Okay, so for 5 and 6, we're referring to the following setting: a stat class with 136 students. Professor, that's a lot of students. The professor records how much money in dollars each student has in his or her possession during the first class of the semester. And we obviously show a histogram where the majority of students are in the first class, which is the least amount of money, $0 to $10. And then it descends from there. There's a large gap between 60 and 100. And then there's like one kid who's carrying over $100 on him for whatever reason. And the question is, the percentage of students with less than $10 in their possession is closest to what? The percentage of students. We can see that the number of students is about 60 out of the 136. So what is 60 divided by 136 closest to? The answer is, I think, what? C, right? Yep, C. It's closest to the 45% mark. Nothing else was really all that close. Number 6, which of the following statements about the distribution is not correct? We could see A, it's definitely right skew. The tail goes all the way out to the right outlier. B says the median is less than $20. Obviously, that's also correct. The vast majority of values contained in this histogram are below the $20 mark. The IQR is $35. Well, if you find the first quartile and the third quartile, you can measure that distance. And let's save ourselves the trouble and see if D or E stand out as being not correct. D, the mean is greater than the median. We said that the mean is not resistant to the pull of outliers. There's clearly an outlier on the high end. Therefore, that would be a correct statement. The mean is greater than the median. E, the histogram is unimodal. It is. There's only one mode there. So even without finding out what the actual IQR is, the answer is C. Okay? So sometimes you could save your trouble of doing extra calculations. In this case, A, B, D, and E were clearly correct answers. We're looking for the one that's not correct. Number 7, 40 students took a stat exam having a max of 50 points. The distribution is given below. They have stems of 0, 1, 2, 3, 4, 5, and the leaves that follow, and they are ordered. The third quartile of the score distribution is equal to what? Well, the third quartile in a group of 40 will be the value at what point? Well, this group of 40, so let's say around the 20th is the median, so around the 30th will be the third quartile. You just count in, and you'll find the answer is B, 44, fits the bill as the third quartile. It also repeats 4 times, so even if it's between this value or that value, it's the same number, it's 44. 8. The mean salary of all female workers is $35,000. The mean salary of all male workers is $41,000. What must be true about the mean salary of all workers? Okay, well, if the mean salary of females is 35 and the mean salary of all males is 41, I think it stands to reason that it's going to be probably in between the two. We don't know if there's more males than females or vice versa, which would weigh the mean in one direction or the other, but it's still going to fall between $35,000 and $41,000. So that's the answer. Number 8, again, is C. Any number between $35,000 and $41,000. Okay. 9 and 10 refer to the following setting. A survey was designed to study how business operations vary according to their size. Companies were classified as small, medium, or large. Questionnaires were sent to 200 randomly selected businesses of each size. Because not all questionnaires in a survey of this type are returned. Oh, got doctors now. Researchers decided to investigate the relationship between the response rate and the size of the business. Okay, long story short, when surveys are sent out, they're not always returned. I'm sure you've received a survey in the past that you didn't answer. Probably this week, when there's an Infinite Campus survey for whose video you liked best for the social emotional learning targets. Hopefully you chose math. So, we have whether they responded or not. That's the response, yes, no. And then the size of the business, small, medium, large. And we see the numbers that are listed in each one. Question is, of course, is there a relationship? So do people in small companies respond to surveys more than those in large, vice versa? Yes, no, no difference, who knows? Number 9, what percent of all small companies receiving the questionnaire responded? So of all small companies, this is the two-way table we talked about earlier in the year. Of all small companies, well, we had 200 small company surveys sent. And what percent responded? 125 over 200. So what percent do we get from that? The answer is E, 50.8%. Yes? Let me just make sure I'm reading the right thing. Yep, 125 out of 200%, that's 62.5%. Wait, hold on. Number 9. Yeah, E. I read the right letter, I read the wrong number. E is 62.5%. So it's I was right with the math. 125 over 200 is the right proportion. That's the answer to is E, 62.5%. Sorry about throwing you with the number. Now, number 10. Which of the following conclusions seems to be supported by the data? Now be careful, because when you're looking at what the data says, it's not always definitive. It's what it appears to be, but let's read. A says there's more small companies than large companies in the survey. No, there were 200 of all small, medium, and large. So that's wrong. B, small companies appear to have a higher response rate than medium or big. Well, we just figured the small response rate was 62.5%. In medium, 81 over 119, and in large, 40 out of 160. That's the right answer. 81 out of 200 versus, so 81 versus 119, and in large, 40 versus 160. Because the sample sizes were all 200, it's pretty easy to see that small companies had a higher response rate. Okay, so number 10 is B. 11 experiments conducted to investigate the effect of a new weed killer to prevent weed growth in onion crops. 2 chemicals are used, standard weed killer C, new chemical W. Both chemicals were tested at high and low concentrations in a total of 50 plots. The percent of weeds that grew in each plot was recorded. Here are the box plots of the results, which the following is not a correct statement. Just take a look at each of these box plots. The W, low concentration, is a very widespread box plot, and the median looks like it's around 25-ish. No outliers. The C, the standard chemical, low concentration, had a higher, lights keep going off, had a higher shifted box plot, which meant that more weeds on average are growing with the standard chemical. Much higher median, about 35% had weeds growing, so that's not so good. The new weed killer at a high concentration has a fairly uniform box plot, except for there's 3 outliers in the high end, and the median growth is under 20%. And in a high concentration of the standard, more consistent results, but still has a higher center than the new distribution. So what are the answers we're looking for? The one that's not correct. Number 11 again. Part A, at both high and low concentrations, the new chemical W gives better weed control than standard. Well, I don't think that's totally right, because the high concentration of standard has a much more consistent spread and much lower center, not much, but lower center than the W low. B, fewer weeds grew at higher concentrations of both chemicals. What am I looking for? The one that's not right? I'm looking for the one that's not right. Okay, let's reevaluate. Okay, so let me just talk about A again. It says at both high and low concentrations, the new chemical gives better weed control than the standard. Technically, here's where we're going with technically. The medians for W are both lower than the medians for both C. If you compare low to high concentrations, you get a little bit of wiggle room here, because I think that the high concentration C seems to be better in some cases than the low concentration W. But let's just keep reading to make sure there's a clear answer. Sometimes, like I said, there'll be a clear answer rather than one that has ifs and maybes. B said fewer weeds grow at higher concentrations of both. That's true. Higher concentrations of both of these do result in better control of the weeds, a lower growth rate. C says the results for the standard weed killer C are less variable than those for new chemical W. That's true, because again, variability is the size of the spread of the box, and both C are pretty narrow boxes, but both W are wider. In fact, the high concentration W is very wide with 3 outliers in the high end. So I'm not sure that that was a great chemical, but that was a correct statement, and we're looking for the one that is incorrect. So now we're on D. High and low concentrations of either chemical have approximately the same effect on weed growth. No. Now you could see that there's a difference here. A pretty standard visual difference. The medians are all over the place. The spreads are all over the place. They're not about the same. So D stands out right now as being a bad answer, which means it's the one you want to choose, because we're looking for the wrong response. Just to check, E says some of the results for the low concentration of weed killer W show fewer weeds growing than some of the results for high W. Low W versus high W, there is overlap. So that was a correct thing to say, which means it's not the choice we're looking for. Okay, great. Now, I said you did not have to do 12 and 13. So hopefully you didn't spend your time doing 12 and 13. If you did, for some reason, I'm going to show you what 12 should look like. Again, it's really up to how you listed it, but there's a picture of a histogram that's fairly appropriate for number 12. And number 12 looked like there might have been outliers. Let's see, if you answered it, you didn't have to. But 12B, takes forever to find it. Yeah, 151 minutes was an outlier. If, again, you did it. You didn't have to. When there's an outlier, this is important to know, whenever there's an outlier, the median is a better measure of center than the mean. The mean is not resistant to the pull of outliers, but the median is. Anyway, and 13 was another one. You didn't have to do it. You could graph it if you wanted to. It's not really worth taking the time with, but if you wanted to pause and look at the answers, you could always do that as practice. Okay. But you probably did not. So 14, back-to-back stem plot shows the lifetimes of several brands of X and Y batteries. I know we didn't specifically spend much time on back-to-back stem plots. However, they're easy to read. The stem in the middle is for both of the plots, and the leaves spread out on both sides. It doesn't require that much explanation, I think, because it's fairly clear to understand. A, what's the longest that any battery lasted? Well, obviously, if you look at the longest any battery lasted, it looks like 55 to me, and that stands for 550 to 559 hours, because it's written as the stems are hundreds, and the leaves are the tens places. So between 550 and 559 hours, because it was less than 560. Okay, B, give a reason someone might prefer battery X. You could see that battery brand X has more batteries that last, let's say, on average, longer than Y. Y has batteries that show up in the 170, 220, and 260 slots, which are all lower than brand X, which has at least 300 hours of life. It's more consistent. Brand X, between 300 and 430 is the vast majority of the value. So it's very consistent, it's very reliable, with a couple of outliers. Okay, and C says give a reason you might prefer Y instead. Well, even though Y has a couple of low outliers, which would be unfortunate if you had been relying on those batteries that died that early, the majority of its values are actually higher on the lifetime scale, between 420 and 500 hours. So that's a reason why you might prefer that. Yeah, it's not as consistent or reliable, but the majority of them do last longer than the majority of brand X. And number 15. During the early part of the 1994 baseball season, many fans and players noticed the number of home runs being hit seemed unusually large. That would be steroids. Here are the data on the number of home runs hit by American League and National League teams in the early part of the 94 season. Compare the distributions of home runs for the two leagues graphically and numerically. Write a few sentences summarizing. Graphically and numerically. So what are they looking for? Well, numerical summaries could be mean, median, mode, range, standard deviation, outliers, all that good stuff. Graphically, box plot's probably a good choice here. So let's see. Well, the book chose a box plot, and they show the American versus the National League, and I'll show you that right now. So here is the box plot. As well, below it are some numbers. I'll explain those in a minute, but here's the box plots comparing the two. So pause and look at them if you want, and you can compare. Now, what that showed you, the box plots, and that's descriptive. It's GSOCs we're looking for next. But that's the box plots for the graphical. For numerical, the mean of American was 56.93. The mean of the National was 50.14. The median of the American League, 57.5. National League, 50.5. The American League had minimum of 35, max of 77. National League was 29 to 67. The Q1 for American was 49. For National was 46. Should I just work in the dark? What do you think? It's going to be easier. There's a motion sensor and no one's moving in here, so that's why it keeps going off. Q3 for American, 68. National, 55. It's just going through the point by point for numerical descriptors. Now, GSOCs, take a look at it, okay? I'm going to read what they have here, but then we're going to maybe fill it in a little bit. Both distributions are roughly symmetric, although there are 2 low outliers in the National League. You should find the outliers mathematically before you call them outliers. The data suggests the number of home runs is somewhat less in the National League. All 5 numbers in the 5-number summary are less for the National League teams than for the American League teams. However, there is more variability among the American League teams, with a standard deviation of 12.69 compared to 11.13 for the National League. Okay. You can also say gaps and clusters. The National League has a gap, and it's demonstrated by the fact that there's 2 outliers in the low end and a fairly large gap between them and the new low value. The American League has no such thing. So the shape, American League and National League were both roughly symmetric, like we said, but if you consider the National League as 2 low outliers, it's got a bit of a skew to the left. Outliers we just mentioned, so you want to show the formula for determining outliers. 1.5 times the IQR lower than Q1 or above Q3, and then say mathematically, these are outliers. Center, because there are outliers, it's probably better to compare medians, 57.5 to 50.5, versus the means, which were actually pretty close anyway, 56.93 to 50.14. Still, clearly, there was a higher center for the American League than the National League. And we have the spread. So what's the range of data from high to low? And clearly it was in the American League, just subtract max minus min, and you got 42. And in the National League, you've got 38. So American League was more variable, and clearly that stands out for them to be as different as they are, given that they're both professional baseball players, leagues. They should be roughly similar. And again, I believe that was the year we had Sammy Sosa and Mark McGwire, with lots of, let's say, drama in the use of steroids. Okay. That was the review of that practice test. Now, what else did I need you to do? That's a great question. Thanks for asking it. We're going to have our test next week. So it's going to be Tuesday, Wednesday, Thursday, Friday. Unfortunately, it's 4 days. 2 days in class, which is required because we have multiple choice. The first day you're here, and we have the free response the second day you're here. On the days you're not here, I'm going to be posting short videos which will basically direct you to study for the test if you have not yet. And if it's after you finish the test, because half of the class will have already finished by Friday, there will be work to do in terms of a vocabulary review using your note cards and or Quizlet from Chapter 4 words, which were the summer work. Okay, that's it. So far as like weekend work, just study. We'll do one last review on Monday, but study and make sure you're ready. If you have any questions, of course, you can always send me a message. We will probably be doing a Google Meet on Monday during the time frame of the class. And if you want to join, you can. You don't have to. But on the Google Classroom banner, there is the class code for a Google Meet. We'll be using that on Monday. Have a great weekend. Let me know if there's any problems or questions. And that's all I got.